Hi everyone! Today let's talk about section 11.6, Calculus of Vector Value Function, and 11.7, Motion in Space. Suppose the position of a moving particle is given by vector value function gamma of t. The displacement from time t to time t plus change of t equals change of gamma, so it's the difference of gamma. Okay, gamma of t plus change of t minus gamma of t. The average velocity from time t to time t plus change of t is given by change of gamma over change of time. Okay, so in terms of the picture, we have here, let's say this is gamma of t, and then here we have gamma of t plus change of t, and then the difference is a vector. Okay, so this vector is change of gamma. Okay, and we use it to divide it by change of t. That will give us the average velocity. The derivative gamma prime of t of a vector value function gamma is defined as follows. So we have gamma prime of t equals d gamma dt. That's the change, the limit when change of t goes to 0, change of gamma over change of t. Okay, so it equals to that. It's very similar to what we learned before in Calculus 1, but instead of just a scalar value function, now we have a vector value function, but each coordinate functions will work the same way as before. And then linear approximation works just like it did before. Change of gamma is approximated by the derivative times change of t, as long as the change of t is small. So convenience formula for the derivative for gamma of t, so we consider it as a column vector. It has 3 coordinates, functions x, y, z. Then the derivative is, we take the derivative of the coordinate functions respectively. Very simple, right? So let's look at the example. We compute gamma prime of t for gamma. Okay, so gamma prime of t equals. Okay, so we can take the derivative of e to the 2t, and we take the derivative of cosine 3t. We take the derivative of 4t cubed minus, okay, here. It's better to separate into the coefficients and the powers of t. Okay, so here I want to remind you like all the differentiation rules. E to the kt derivative is k times e to the kt. Okay, and cosine kt derivative is k times derivative of cosine is minus sine. Okay, so for more differentiation formulas, please go to our website and check out the worksheet in the first week. I provide you the algebra formula sheets and the calculus formula sheets. You can review all of those. So that's why the first coordinate we get 2e to the 2t. The second coordinate we get negative 3 sine 3t. Derivative, so 4 times 3 is 12t squared minus square root of 7, and then we put the 1/2 in front. Times t to the 1/2 minus 1 is negative 1/2. Okay, so that is the derivative. So far so good, everybody? Let's continue. Physical interpretation. Suppose the position of a moving particle at time t is given by gamma of t. Then the first derivative, gamma prime of t, gives the velocity or tangent vector of the particle at time t. The second derivative, gamma prime t, gives the acceleration a of t of the particle at time t. While the speed is given by the scalar quantity, do you remember in Calculus 1, the speed is just the absolute value of our velocity. And here, because we're working with vector, instead of absolute value of a number, we have the length, the magnitude of a vector. Okay, so the unit tangent vector, well, first is the tangent vector, and it's also a unit vector. Unit vector means the length of it is 1. So we have the tangent vector divided by the length of it. Okay, so this is the same as v of t divided by the length of v of t. Okay, so that will give us the unit tangent vector. Next, important geometric property. For any given value t equals a, the vector gamma prime of a is tangent to the curve parameterized by gamma of t at the point where t equals a. Okay, for example, we have a curve look like this. Okay, so at any points like here, then the vector, so this is v of t, okay, is tangent to the curve at that point. Next, derivative rules and integral rules. The rules for derivative for single variable functions either carry over directly to vector value functions or have close analogs. Okay, so let u and v be differentiable vector value function, and let f be a differentiable scalar value function, all at a point t. Let c be a constant vector. Then derivative of constant vector is 0. Okay, so this is, you see I bold, this is 0 is a vector. Okay, and then derivative of u plus v is u prime plus v prime. This is the sum rule. And for difference is the same thing, right? For difference and constant multiple, it works the same thing. So if this is minus, this is minus. Okay, and derivative of a scalar value function times a vector value function, we have the product rule. F prime v f plus f times v prime, and this guy is a vector. This guy is a vector, so that the sum will give us a vector. Next, for chain rule, if we have u of f of t is gonna be u prime of f of t times f prime of t. Okay, this is the chain rule. Next, we have the dot product rule and the cross product rule. It works very similar as our regular product rule. Okay, the derivative of the first guy times second guy plus the first guy times the derivative of the second guy. But just the times, sometimes it could be dot if we're working with dot product. Sometimes it could be cross if we're working with cross product. Okay, so let's look at this example. The position of a moving particle at time t is given by gamma of t equals t minus sine t, 1 minus cosine t. Compute the position, velocity, and acceleration vectors at time equals 0, pi, and 2 pi. Okay, so gamma of t is the displacement, right? And then gamma of 0 is 0 minus sine of 0 is 0, and 1 minus cosine 0 is 1. Oh, so the answer is 0, 0. And gamma of pi, okay, so pi minus sine pi, so what does sine look like? Like this. What's cosine look like? Like that. So sine of pi is also 0. But cosine of pi is minus 1. So we get pi in 2. How about gamma of 2 pi? Well, 2 pi minus sine 2 pi is 0. 1 minus cosine 2 pi is 1. So we get 2 pi and 0. Okay, so let's look at the graph that corresponds to this point. We have 0, 0 here. That is, pi is like 3.14 somewhere. So this is pi and 2. See, this is 2. Then this guy is 2 pi and 0. You see, it oscillating is a 2 pi like a period. Okay, let's continue. How about gamma prime of t? Okay, so v of t is then, sorry, sometimes I forgot the arrow. Okay, but try to include the arrow because we want to distinguish is a vector, is not a scalar function. Okay, gamma prime of t, so we have t minus sine of t prime, 1 minus cosine t prime. So t derivative is 1, derivative sine is cosine t. Derivative 1 is 0, derivative cosine is minus sine, but minus minus become positive, so this is positive sine t. Then v of 0 is, I'm going to put in here, cosine 0 is 1, sine 0 is 0, so we have 0, 0. v of pi, cosine pi is minus 1, sine pi is 0, so this is 2, 0. Okay, and then v of 2 pi, cosine pi is 1, sine pi, 2 pi is 0, so we have 0, 0. Okay, what does that mean? Well, if I use the if we use the green color as 0, the velocity is 0. It kind of have no direction there for the tangent vector. At the point pi 2, the velocity is 2, 0. So 2, 0 is like this. Okay, so it's going to the right. Okay, and then at 2, 0, the velocity is also 0. So it kind of have no direction at that point. No velocity at that point. 0 velocity at that point. Okay, let's continue. Then we have acceleration. Acceleration is the derivative of the velocity. Let's see. Derivative of 1 is 0. Derivative of cosine is sine. So, sorry, derivative of cosine is minus sine, but because there are two negative, multiply together, give us sine t. Derivative of sine t is cosine t. So, a of 0, sine 0 is 0. Cosine 0 is 1. Okay. And then a of pi. Sine pi is 0, cosine pi is negative 1, and then a of 2 pi, sine 2 pi is 0, cosine 2 pi is 1. Okay, so what does that mean? So if we use this different color, let's use blue to indicate. So at the point 0, 0, we get the A is 0, 1. So 0, 1 is right here. Okay, and for the second point, we have 0 minus 1 is right here. So 0, 1 is right here. So this is like the force we're pulling it. Okay, at this point, our force is pulling up, and then here we have a force pulling down, and then here we have a force pulling up. So far, so good. Okay, let's continue. Why is that? Because the Newton's law, F equals ma, right? Force equals mass times acceleration. So force and acceleration are in the same direction. Okay, let's continue. So it's great to combine your physics knowledge with these concepts, okay, in this session. Next example, we want to find a unit tangent vector for functions. Okay, let's see. The first guy, in order to find a unit tangent vector, we need to find a tangent vector first, right? So to find the tangent vector, we want to take the derivative of that. Okay, now let's see. V of t is the derivative of each coordinate Derivative of 5t squared is 10t. Derivative of t is 1. Derivative of 3t to the 5th, 3 times 5 is 15. T to the 4, derivative of 4 is 0. Derivative of 11t is 11. Okay, to find the unit tangent vector, we find the tangent vector, and then we find the length of the tangent vector. Well, it's the square root of each coordinate square. What is that? Well, let's see. So let's simplify it, and this is 100t squared minus 20t minus 1 plus 1 plus 15 squared is 225 t to the 8 plus 1 to 1. Okay, so this is the same as we order it from the largest power, and then it's 100t squared minus 20t, and then combine the constant 122. Okay, so that is the length. So then the unit tangent vector is the tangent vector divided by its length. So that equals, oops. Okay. I don't want to copy the length 3 times. So let's just do 10t minus 1, 15t to the 4, 11 all over this length. Okay, 225t to the 8 plus 100t squared minus 20t plus 122. Do you have the same answer? Okay, let's continue. So for part B, what is v of t? Okay, v of t is derivative of 2, 0. But this guy, we use product rule. What is product rule? Okay, here. Product rule means it's the derivative of the first guy times second guy plus first guy times derivative of the second guy. And then here we also have product rule. First guy prime times second guy plus first guy times derivative of the second guy. Okay, let's see. This is negative e to the minus t sine 4t, and then derivative of sine is cosine, but because of chain rule we have 4 e to the minus t cosine 4t. And then here minus e to the minus t cosine 4t plus derivative of cosine is minus sine, but because of chain rule there is extra 4 in front, and this is sine 4t. So far so good. Okay, how about the length of that? Ooh, it's gonna be a long line. Is the first coordinate square plus the second coordinate square. Okay. Oh, my line is too long. Okay, so all right, let's see what are these. I don't have much space left. I'm gonna write very tiny. So the first guy, square it. Negative 1, cancel it, but e to the minus t squared is my e to the minus 2t, right? X to the a to the b is x to the ab. X to the a times x to the b is x to the a plus b. So keep this in mind. Then we have sine 4t squared plus 2 times 4. Okay, so this is minus 2 times 4 is 8. we'll have e to the minus t times e to the minus t is e to the minus 2t. And then we have sine 4t, cosine 4t. Okay, and we also have the second term squared. So 16 e to the minus 2t cosine 4t squared. Okay, and then let's look at the next complete square. We have the first guy square, and then minus minus become plus. 2 times 4 is 8. E to the minus 2t cosine 4t sine 4t. Plus second term square, 4 squared 16 e to the minus 2t sine 4t squared. And this is all within the square root. Okay, next, open your eyes. Look at this guy and this guy. They combine together. You can see we can factor out e to the minus 2t, and then we get sine squared plus cosine squared is 1. So that's why this will give us e to the minus 2t. And can you see this guy and this guy cancel? And this guy and this guy, we can combine them. It gives us 16 e to the minus 2t. Also, sine squared plus cosine squared equals 1. So at the end, we get 17 square root. And then e to the minus 2t square root becomes e to the minus t. So what is the unit tangent vector? Well, it's going to be, well, the v of t divided by that. Can you see all the e to the minus t is gone? Yes. So that's why we have minus 1 over square root of 17 sine 4t plus 4 over square root of 17 cosine 4t. Here, minus 1 over square root of 17 cosine 4t minus 4 over square root of 17 sine 4t. So all the e to the minus t are gone because they cancel out. They cancel out with this guy in the denominator. So far, so good, everybody? Okay, this is this example, and let's continue. Okay. Yeah, sometimes we run out of space, sorry, because I do want to include an example in the page. I don't want to separate into 2 pages, even though I think maybe we should need more space, but it's hard to separate a problem into 2 different pages, right? Okay. Let's continue to look at this example. Uniform circular motions in R2 given by R of t equals R. R is the radius. R cosine omega t, R sine omega t, where R and omega are constants. Answer the following questions. A. How long does it take the particle to make 1 full turn around the circle? Okay, let's see. So full turn around the circle is asking like the period. All right, so this is the radius r, right? And we know if it's r cosine t and r sine t, then the period is 2 pi. So if we have a cosine omega t and sine omega t, then the period equals 2 pi over omega. So far, so good, everybody? Okay, why is that again? Think about that. If you have r cosine t, r sine t, then you have a picture that if t is 0, you're at this point, t is pi over 2, you're at this point, t is pi at this point, t is 3 pi over 2 at this point. Okay, so the period is 2 pi, so like a t equals like 2 pi. But in this case, now you replaced t by omega t, so omega t equals 2 pi. It means the t is 2 pi over omega. So the period becomes 2 pi over omega. So part B, what are the velocity and speed of the moving particle? Velocity is the derivative of the displacement. So derivative of cosine is minus sine, but because of chain rule, we have r omega sine of omega t. Okay, derivative of sine is cosine, but because of the chain rule, we have r omega cosine omega t. And what is the speed? Well, it's square root of each coordinate square. So r squared omega squared sine omega t squared plus r squared omega squared cosine omega t squared. Now what happened? We can factor out r squared omega squared. Then we have sine omega t squared plus cosine omega t squared. So no matter what the angle is, sine squared plus cosine squared equals 1. Then square root of r squared is r, square root of omega squared is omega, so the speed is r times omega. So far, so good? Okay, let's continue. See what are the acceleration and the magnitude of the acceleration. So acceleration a of t equals the velocity the derivative of the velocity, right? So derivative of sine is cosine, but because of the chain rule, you have extra copy of omega multiplied by it. Cosine omega t. And then derivative of cosine is minus sine, but because of the chain rule, we have an extra copy of omega multiplied by it. Sorry. This is sine of omega t. This is the acceleration, and what is the magnitude of the acceleration? It's r squared omega now to the fourth. We have cosine squared plus square omega to the fourth sine omega t squared. So we can also factor out r squared omega to the fourth, and then we get cosine squared plus sine squared that equals 1. Same trick as before, right? So we have just r squared omega to the fourth. This is r times omega squared. So this is the magnitude of the acceleration. So far, so good? Alright, let's continue in video part B. See you soon!